Okay, everybody is very welcome. I'm going to give it another 30 seconds or so just to let some people filter in, although they will filter in sort of as we go. I would like to welcome you all to this webinar. It is the last of the year. Let me, at the very beginning, just give you some sense of what's happening next year. We've got some dates. You'll get them by email if you're registered for this. But the plan is to have it sort of quarterly next year. So we'll do four in February, May, September, and November are the dates. So look out for those. For those who celebrate, it's on my Christmas party today. So I've got my flashing light Christmas jumper on. And I'm very excited to welcome, one of my co-authors and one of my students serving a dual purpose. And also, happy birthday, because it is also his birthday today. So this is his present he gets to present today. So Matt, the format is you will have about 45 minutes. During that time, present away. I will interrupt you if there are questions. People in the audience, if you have questions, there is a Q&A facility. Put your question in there and I'll try and drop it in at an opportune moment. And then at the end, we have at least sort of 15 minutes or so for discussion. And then if we overrun a bit, we overrun. But the plan is to finish sometime between 4 o'clock UK time and 4:15 is the absolute deadline cutoff. Okay, do you want to start sharing your slides? And
Let
they
me know if you can
are,
see them.
they're coming. At least they're telling me they're coming. They are there. Yep, excellent. Okay, I hand over the floor to you and just remind the audience if you do have questions, Q&A facility, and I'll drop them in when I can.
Thanks, Michael, and thanks for reminding everyone that it's my birthday. I haven't got my Christmas jumper on, but hopefully the topic is festive enough, or at least brings enough cheer for the festive season. So the title of the paper is "Anchors Aweigh: The Effects of Communicating Forecast Uncertainty." This is co-authored with Michael, as he said, but also Ryan Rolls and Peter Rickards, and some of the authors work at central banks. So I very clearly say that the usual disclaimer applies, that these are our views alone. So I will begin with a quote from Alan Greenspan in 2004, who stated that uncertainty is not just a pervasive feature of the monetary policy landscape, it is the defining characteristic of that landscape. And of course, there's a large theoretical literature on monetary policy and uncertainty. There's a more nascent empirical literature looking at how uncertainty influences monetary policy in practice. But what we look at today is how to communicate uncertainty. And in particular, there are a couple of challenges to communicating uncertainty. So the first challenge is uncertainty communication is important, but difficult. And in particular, we propose or hypothesize that there's likely to be a dynamic trade-off between influencing beliefs and expectations today and influencing them tomorrow or in the future. So what do we mean by this? Well, in relation to today, central banks or forecasters more generally may incur a cost of communicating uncertainty insofar as they are literally admitting that they may be wrong, i.e. they're most likely to be wrong in most instances. And the cost of that might be that people sort of place less weight on a central forecast, and that might anchor expectations less strongly around that forecast. Now, there may also be, and there are sort of three papers in this literature that sort of find evidence pointing towards that. Now, in addition to the costs, there may also be benefits today of communicating uncertainty. In particular, that helps people to understand uncertainties present, or the fact that there may be uncertainties present. And there isn't any literature looking at this, or evidence looking at this, to the best of our knowledge. Now, there may also be benefits that you reap in the future. And in particular, by communicating uncertainty and acknowledging and being transparent that you may be wrong in the future, there may be errors to your forecast, that may help to protect sort of your reputation, and and sort of manage expectations in a sort of dynamic, repeated game setting. And there isn't any evidence in relation to this within the field of economics, again, to the best of our knowledge. But there is some evidence in sort of other fields, more generally, pointing towards the positive effects of communicating uncertainty transparently on, for instance, trust. So this is the first sort of broad economics challenge. The second challenge is a more sort of policy-specific one. And in particular, there was a review of the Bank of England conducted last year by Professor Bernanke, in which one of the recommendations was the following. Despite their distinguished history, the fan charts as published in the NPR have weak conceptual foundations, convey little useful information over and above what could be communicated in other more direct ways, and receive little attention from the public. He goes on to say that they should be eliminated, and yet it remains important to communicate the degree of forecast uncertainty and the balance of risks. So with these two challenges, what we do in our paper is a two-part exercise. In part one, we simply try to understand the degree to which different media or forms of uncertainty communication are understood by different audiences, the degree to which they're able to explain uncertainty. Now, as part of this experiment, we test the interpretation of uncertainty across different mediums or media, including fan charts, dot plots, box and whiskers, ranges, and a variety of other forms of communication. And from that, we gauge people's understanding of sort of the central expectations or projections within those forms of communication, the distributions, and probabilities around the distribution. And as part of this experiment, we have both a UK general public, but also a technical audience as well. Then in the part B of our two-part experiment, we conduct a dynamic information provision experiment where we test the effect of communicating uncertainty. And here we have a representative sample of the UK general public with 1,600 observations. And the long and short of the exercise is that it's split into 4 stages. So in stage A, we provide participants with a back history of inflation and elicit expectations for inflation and confidence ranges around those expectations. In stage B, we then treat them with a central bank forecast, and that forecast is either a point forecast or a point plus some demonstration or depiction of uncertainty. In stage C, we reveal a forecast error, and then in stage D, we provide them with an updated central bank forecast. And this is the sort of dynamic element of this exercise. And throughout, we incentivize participants to sort of forecast accurately and have sort of sensible confidence ranges. So the summary of the findings is quite clear. Fans do quite well across both experiments. Now, in more detail, in experiment number 1, the fans turn out to be well understood and the best at jointly conveying both expectations and uncertainty around those expectations. And this is true for both the public and for experts. Now, in part B, we find that initially, point forecasts anchor expectations marginally more than fans. And this is in line with the previous work that I mentioned earlier. However, that's in a one-shot game. However, in a dynamic setting in which people observe forecast errors, we find that errors de-anchor expectations, in particular, unlucky errors, which we'll explain later on, but essentially when the error takes a series away from the central bank forecast rather than towards it. And fans are able to materially mitigate this de-anchoring, i.e. they provide some sort of insurance policy against this de-anchoring that occurs after people observe a forecast error. And in providing this insurance policy, the fans, this could have implications for the degree to which fans are able to sort of maintain the central bank's reputation and engagement in their forecast. Now, result number 3 is that central banks, following this error, can partly re-anchor by providing an updated central bank forecast, but they do so to a lower level than prior to the error. So there's a sort of persistent effect of having observed the forecast error on the degree to which central banks are able to anchor expectations. Then the fourth result is in relation not to expectations, but to uncertainty. And in particular, the public, while we find that the public sort of consistently underestimate the degree of uncertainty in the environment, i.e. are overconfident, the fans help to sort of enable the public to learn what more sensible confidence ranges maybe. Very quickly on the literature. So I mentioned previously that there's sort of an established theoretical literature on monetary policy and uncertainty, which we don't touch. There's a sort of more nascent empirical literature on how uncertainty influences monetary policy in practice, which we don't really touch. Our fields that we're sort of contributing to today is this effect of communicating uncertainty, where within the field of economics, there's evidence on the impact of sort of point forecasts versus uncertainty communication in a static one-shot game setting. Whereas our sort of main contribution is to test the effect of communicating uncertainty in this dynamic repeated game setting. Okay, so on to part A. I can't see questions, Michael, so I guess you're shouting if there are any.
I will interrupt as soon as it's sensible to.
Perfect. Okay, so on to part A. So essentially for this part A exercise, we have two samples of participants. So we have 300 representative members of the UK general public, and 70 which are recruited via Prolific, an online survey platform, and 75 expert sample, which are made up of sort of PhD economics students, financial market participants, financial journalists, and central bank staff. And these were sort of recruited via our networks. So each participant is randomly assigned to 3 out of 6 possible baseline forecast projections. And we sort of distinguish here between unconditional and conditional forms of uncertainty communication. So unconditional meaning sort of general uncertainty, conditional meaning sort of context-specific asymmetric sources of uncertainty. And I've grayed out the fact that participants also observe 2 out of 4 possible sort of conditional forms of uncertainty, i.e. scenarios, because we don't have time to go through that today. We have stuff in the appendix if we have time at the end. But we'll focus on sort of the unconditional media for now. So having observed these sort of baseline projections, we then ask a variety of questions to sort of gauge how much they understood from these different forms of uncertainty communication. And within each chart, just to note, within each sort of uncertainty form of communicating uncertainty, each participant observes a different world for each type of uncertainty. And these worlds are sort of randomly assigned in order and across treatment. So onto the actual media that they see. So of course we have the classic only point forecast. We have the classic, at least within the UK context, fan chart, and we also have 4 other forms. So the third is a range where we have sort of these dots to represent sort of the 99% confidence interval, and then box and whisker charts, which are sort of in discrete time space, followed by dots, i.e. to represent or to reflect US FOMC dot plots. And then finally, we have this speedometer, which was a sort of innovation. I'm going to pin the blame on Michael. It was a Michael innovation, which seems to have not gone down particularly well with our participants, at least in terms of how much they say they liked it. But the idea is that it has a central projection and communicates uncertainty around it in sort of discrete time space rather than continuous form like a fan.
I'm gonna jump in just to justify myself and defend myself here, which is it's actually something that has not been used in this form, but has been used by a number of central banks, including the Bank of England, as a way of depicting sort of inflation being too high or too low. Sort of capturing the public's general understanding of how speedometers work. Now, I guess the bit which I'm happy or willing to take the blame for is the the attempts to add a fan chart around this may have been imperfect. So I'll take that, but let's not ruin the results for everyone. I will, since I've interrupted you and stopped your progress anyway. I'm gonna put Winnie's question to you. First of all, she says happy birthday, so that's the important thing. No, but she asked, what kind of channels do you have in mind on the consumer side? Is it trust in the central bank, sort of an institutional setting, credibility in achieving the inflation target, or where would you answer for that?
So I assume that the question relates to sort of the part B, the dynamic provision experiment, rather than part A, where we're just trying to understand whether people understands the material and information conveyed. So in relation to the part B, I guess this comes back to this dynamic trade-off that we're trying to emphasize, whereby in the sort of in the immediate term, conveying uncertainty will or could reduce the weight that people place on sort of the central projection, i.e., there's a risk that people anchor to that central projection less. But the idea is exactly as you suggest. In the long run, if you're admitting ex ante that you may be wrong, then when you are wrong, there's a world in which our hypothesis is there's a world in which people don't lose so much faith. So it's a trust channel. It's a reputation, credibility, trust channel through which or following those errors, right? So the fact that you have flagged that you may be wrong and accepted that you may be wrong, when you are wrong, having done so ex ante could sort of make people lose less faith, is the argument. So it's basically the channel that you suggested.
Yeah. Let me add one extra bit, because I guess one natural response to your question, which I guess people would have, is sure, but like how many people actually look at the fan chart, or whatever the ECB or Fed put out, how many real people look at that? And I guess my answer to that is that's probably true. But it's also true that some of the people who look at it and serve as intermediaries of these messages are not all sophisticated economists who, write for the sort of highbrow, the FTs or the Wall Street journals of the world. And so, at least in other work, we weren't able to isolate it here, but in other work, we sort of found that a lot of these attempts to communicate things more clearly, more simply, actually benefit even those with some economics training. So this is not like a kind of there's economist messaging and there's others. We sort of think, and this is where part A will be useful for answering this, that maybe the wider public or the less technical audiences are actually not that dissimilar to the professional technical ones. But yeah, I'll let you get on to that.
But it's a good question. Okay, so I'm going to jump straight into some charts from this part A exercise. So as I mentioned, we ask a sort of variety of questions. The simplest sort of type of question that we ask is sort of to gauge their subjective understanding of the material that we've provided. So very simply, firstly, we ask, to what extent do you think you understand this chart? And here I show the sort of density plot of responses on a 1 to 7 scale of for the point forecast, right? So we see this hump around sort of 6 out of 7, indicating that people, 5 out of 7. I can't see the bottom of the page because of my Zoom link, but 5 out of 7, because which indicates that people sort of understand this relatively well. Now, on top of this fan, on this point line, I'm going to layer on the other forms of communication. So this is the fan chart, where we see the distribution is slightly more shifted to the left. People still sort of think they understand it relatively well, but there are a proportion of people who understand it less well. And then I layer on the rest of the forms of uncertainty communication, and we see that sort of they're progressively less well understood. So I think down here we have, again, I can't see my legend, but we have sort of the speedometer, the box and whiskers that are most sort of left weighted. Now, this is for the general public. and I'm going to layer on the expert responses on top in dashed lines. So here again, we have the point forecast, and what we notice is that most experts, as you might imagine, at least believe that they understand the point forecast rather well. They also believe they understand the fan charts rather well, and the rest of the media sort of slightly less well, and they hate the speedometer. Right. So on the left-hand side, we have Michael's innovation performing not so well. So this is for sort of subjective responses. We also try to gauge their sort of objective understanding of the material and information conveyed. So this is specifically, we ask, what's the most likely value for the series in forecast period 1? This is trying to get at the degree to which they're able to understand that there's a central forecast, which is sort of meant to reflect the modal outlet. Now, the colors of the bars represent the different forms of uncertainty communication. And here we have on the y-axis the proportion of people that get this answer correct with some sort of interval within which we're being lenient. Now, we see that 80% of people with the point forecast sort of forecast this accurately or interpret the information accurately. And then actually across the rest of the forms of media uncertainty communication, people do quite well as well. And these differences aren't statistically significant. I layer on top in the crosses the responses amongst the experts. And again, thankfully, they seem to do quite well. So they basically 100%, not quite, but basically 100% of responses are correct across the different forms of uncertainty communication. So this is to sort of gauge, okay, do they understand that there's a central projection and an essential expectation? We also try to gauge the degree to which they understand the uncertainty communicated. And we do this across a set of questions. Here I provide the most complicated one, and I will talk you through this chart because I know that there's a lot going on. But the question essentially is how likely is it that inflation will be between X and Y%? So we're essentially trying to gauge the degree to which participants are able to assign a probability to a specific range, to inflation within a specific range occurring. Now, if we focus on the top left chart first, which reflects responses for those treated with the points forecast. And again, the bars reflect responses amongst the general public, and the crosses reflect responses across experts. And on the x-axis, we have the different bins of possible options that they could have ticked. And the green X across each treatment reflects the correct answer for that treatment. Now, for the point forecast, of course, the answer is you cannot tell within what the probability of a certain range of inflation occurring. Now, if we look at the expert sample, about 90% of them got that right. So brilliant. They understand that the point forecast doesn't communicate uncertainty. On the other hand, amongst the public, only about 30% get that right, and the others sort of hallucinate degrees of uncertainty. So they try to assign probabilities not based on the information provided, but they hallucinate. In contrast, the fans, we see both experts and the general public, a high proportion of the general public, getting this correct. Similar for box and whisker, similar for speedometer, while dot plots, ranges also confused. So with that, well, I should say, so I'm going to now build this slide which tries to summarize the findings across all questions. And we have run a bunch of regressions in the background. And as I build this table, which tries to summarize these regression results without the various stars, I'll try to walk you through the assumptions behind them, but they're essentially taken from the regression tables and the coefficients therein. So I guess to summarize, is the medium understood? Is it liked? And we provide sort of the regression coefficients rescaled here to get at that question. So the higher the value, the more positive the value, the more people liked that or believed that they liked that form of uncertainty communication. So we see that the point is well liked, the fan is sort of slightly positive, but basically zero, and the others are negative, including the speedometer, which is rather negative. We then ask, how uncertain Do you think the information is in the chart, or how much uncertainty does it convey? Answers close to zero here reflect the fact that the distribution was relatively normal, i.e., people aren't misinterpreting or over or under interpreting the uncertainty. We see that the fan and the range are about zero, same with the box and whisker, but the point rather negative, indicating that people are under interpreting the degree of uncertainty. So then against the point estimate, do people understand the central projection? There were no significant differences across the forms of communication. So these are all sort of 0.8 in terms of the proportion of people who were correct. We then asked 3 questions to gauge their uncertainty. No differences in the degree to which people understand that there is uncertainty. Some differences in the degree to which people understand the distribution of uncertainty, i.e. whether it's normal, and the fan performs better, comparatively better than the others here. And then the regression results for the probabilities exercise that I just showed you in the charts, where again, the fan performs very well. Now, we've got this summary column on the right-hand side, which tries to provide some sort of weighted average of these 4 columns here, which capture people's objective understanding. And the bottom line is that the fans, with different weightings across anchoring and uncertainty, perform well across the board. So we highlight fan as being well able to jointly convey uncertainty and expectation, and well liked. This is across the public. We produce a similar summary table based on regression results for the expert sample, where again the fan performs best and is relatively well liked. So to conclude on the part A exercise in this short presentation, the fan is liked, most accurately conveys information, and as such, we take that forward to part B to focus on the fan versus the point in comparing the effect of uncertainty communication. So on to part B. So the experimental timeline is as follows. So if we look at the red writing first, we see that all negative numbers are time periods that have happened in the past. So we provide essentially participants with 12 years of back history data. And we provide data on the inflation series, but also the central bank forecasts for each period in time. Then moving forwards, participants initially find themselves in year 0 and have when we elicit expectations for year 0, year 1, and year 2. Then as the experiment moves on one period, participants will then find themselves in year 1, forecasting year 1 and year 2 inflation outturns. And year 2 is this sort of never reached future. We never get to year 2. And as such, we refer to it as a sort of medium run concept that never arrived. Now, the stages indicate the information set that participants have at different periods in time. So stage A, people have seen the back history and are forecasting purely based on the back history of inflation outturns and central bank forecast. In stage B, they've observed the central bank forecast and update their priors. In stage C, they've observed the inflation outcome, i.e. the forecast error. And then at stage C, they have observed the updated central bank forecast. And in each stage, they update their expectations for forecasts for year 0, 1, and 2. So some notation before jumping into the results. So we elicit 2 measures for each individual. One of their expected inflation at each period in time, given information set 0, i.e. information set Z, which corresponds to the stages, and their ranges. So each time, we not only ask for a point forecast from the participants' side, but also their confidence interval or range around that. And I will skip through this notation, which, if there are any questions, we can go back to. Okay, so the environment in the background that's generating the inflation series and the central bank forecast is a standard New Keynesian 3-equation model, where backgrounds are model simulations with sort of specific shocks therein. Central bank forecasts are always the optimal forecast that emerges from the model. And central bank uncertainty, i.e. the distribution represented within the fans, is derived from stochastic simulation. Now, as I mentioned, the sample is recruited via Prolific. We incentivize accuracy of forecasts for both proximity of point estimates, whereby people get more money if they're closer to the inflation outturn with their forecast, and range forecasts. We provide a bonus if the outturn is within their range, and that's decreasing in the size of the event. Average time is 19 minutes, average base pay £10.63, bonus pay nearly £2. Okay, so what do the participants see? Well, we show them this back history of inflation and the central bank forecast, and we say the graph below reveals historical inflation data and central bank forecasts, and we would like them to enter a point forecast for inflation for the next 3 forecast years. Showing what that looks like, we have these 3 red point forecasts for the participants to see what they've inputted, and these confidence bands that they can adjust around them. Now, these confidence bands always have the same default width, so we know if people haven't touched the confidence bands at all. Then we provide them with the central bank forecast in purple, followed by some sort of data outturn. Now, at this point, it's worth distinguishing between 2 types of data outturn. Now, we saw in this central bank forecast that the forecast is that inflation rises from about 1.5 gradually to around 2, i.e., inflation is set to gradually increase from year 0. Now, we have 2 different types of, well, we have multiple different types of error, but we distinguish between what we call lucky errors, where the inflation series or the outturn is in the direction of the forecast, and unlucky errors, where the inflation outturn is in the opposite direction to the forecast, i.e., taking inflation away from where the forecast was forecasting it would end up at year 2. Okay, so we have expectations derived at stages A, B, C, and D, and what we use as our main dependent variable of interest is the absolute deviation of the participant I's forecast at each stage from the optimal forecast at that stage. Okay, so some charts. We'll start with some descriptive evidence, and then I'll show you regression tables that confirm the findings that we observe. So here we have the distribution of the absolute forecast deviations for participants in stage A, represented by these purple distributions, for years 0, year 1, and year 2. Right, so if everyone in our sample immediately in stage A was forecasting the optimal forecast, then these absolute deviations would all be 0. Positive values, more positive values indicate greater absolute deviations from the optimal forecast. So we see that in stage A, at which point participants have only seen the back history of inflation in the central bank forecasts, these priors are relatively dispersed, and they become more and more dispersed as they forecast further and further into the future. Now, I layer on the stage B forecasts, which essentially is the effect of, or the absolute forecast deviations after participants have seen the central bank forecast. So we see that the treatment of a central bank forecast anchors expectations. The distributions become much tighter around the optimal, which coincides with the central bank forecast. And this is both at each of year 0, year 1, and year 2. Right, so we get this anchoring from their dispersed priors once treated with the central bank forecast. We then show them the forecast error, which I layer on in orange. And here we see that expectations de-anchor. Right? So they see the error and the distributions become redispersed. And in fact, the distributions look a lot like the distributions prior to any central bank forecast treatment, i.e. prior to stage A. Now, after this, we show in stage D the updated central bank forecast. And we do see a re-anchoring right? So the distributions become tighter once again, but less tight than they had been in stage B before the error. Right? So from this, this is all descriptive, but we show that this holds in the regressions. It looks as though there's a sort of persistent effect on the degree to which central banks can anchor expectations once people see a forecast error. And here we have these summary statistics to essentially confirm that sort of the proportion of people who in year two, say we focus on, in year two are within 25 basis points of the optimal forecast. In stage A, 36% dispersed. We then see the anchoring in stage B to 70%, the de-anchoring in stage C after they see the forecast error to 41%, and the part re-anchoring in stage D to around 60%. Okay, now those distributions were across both treatments. So we weren't distinguishing by treatment, and we weren't distinguishing by the type of error. So now we look at different types of error, and in particular, we focus on stage C, which is immediately after people have seen the error, at which point the expectations we saw de-anchor. And we focus on year two, which, as I mentioned, is this sort of medium run concept that we never get to. So here we show the same distribution as we saw in the previous chart, grayed out to reflect that this is the distribution in stage C across participants, across all errors. We then layer on top participants who saw these unlucky errors. Now remember, these unlucky errors are errors that take the inflation series further away from the year two forecast. And we see that this de-anchoring, the dispersion of beliefs at stage C for people who had the unlucky errors, were treated with the unlucky errors, is more dispersed, i.e. the unlucky errors de-anchored expectations by more. Again, this is a descriptive. We show regression tables in a moment. We then layer on unlucky large errors, because some people were treated with large and small errors, and then large positive errors, unlucky large positive errors. And we see that sort of an increasing of the dispersion, indicating some degree potentially of asymmetry between positive and negative shock. So this is by error, right? The real question that we're interested in is there a difference between the treatments, between being treated with the point and being treated with the fan, where uncertainty is communicated? So we compare the distributions across the points and the fans in this, again, quite complicated chart, so I'll walk you through it carefully. So in the blue distributions are the distributions amongst people treated with the fan. The red are the distributions of people for the people treated with the point. The solid bars are the median. The dotted or the dashed bars are the quartiles, and the dotted lines are the 90%, 10 and 90% of the distribution. We have on the top row the stage A, so the priors. We have on the second row stage B, so once they're treated with the central bank forecast. Stage C, where they see the error. Stage D, when they see the updated forecast. So what we see is that there's no sort of obvious differences between the priors, as you would expect. There's a sort of an anchoring at stage B once they see the forecast across both points and fans. You might say that the point forecast, the red distribution, lies slightly to the left here, which indeed is statistically significant in our regressions, i.e. the point forecast anchors by relatively more initially. We then see de-anchoring across both treatments in the stage C once they see the error, and then a re-anchoring in stage D. Now, what I want you to focus on as I move through these charts is this stage C, where we see some differences emerge as we filter across error types. So these are the distributions across all errors. I then filter to unlucky errors in this chart, and we see that the red distribution, so this is the median in stage C, the red distribution, as we filter to these unlucky errors from the central bank's perspective, people that are treated with the points begin to de-anchor by more than people treated with the fan. So this is unlucky errors, large unlucky errors. We see this red distribution shifting to the right while the blue distribution remains as is. And for unlucky large errors, and we really see this sort of elongation of people of the distribution amongst people treated with the points who were de-anchoring by more than people treated with the fan. And we then look at stage D, and there's sort of no significant differences and confirmed in the regression tables. So we then I will now walk you through the regression tables for those results. So the regression specification is relatively straightforward. We have the absolute deviation, forecast deviations on the left-hand side. On the right-hand side, we have coefficients for the treatment effect, the difference across different types of error, and then the interaction between the two. And I'll build this table up sequentially, but essentially we see that, okay, so people treated with the fan have forecast deviations in stage B that are larger in magnitude than people treated with the point by 3 basis points, i.e. they anchor by 3 basis points less than the point. Unlucky errors seem to increase the de-anchoring in stage C. So here we show the unlucky large errors and the unlucky large positive errors have sizable effects on increasing the de-anchoring. So the unlucky large positive errors increase the degree to which people de-anchored post-error, having seen the error, by 30 basis points more than the counterfactual. And we see that the fans essentially perfectly mitigate this additional de-anchoring. Right? So as we go from unlucky errors to large unlucky errors to large positive unlucky errors, the size of this sort of insurance policy provided by the fans relative to the points increases significantly. And the magnitudes of these coefficients are sizable. I mean, the fan here is mitigating the de-anchoring by 30 basis points. And we can compare that sort of in magnitude to the initial degree to which the point anchored by more, which is only 3 basis points, i.e. a factor of 10 greater. We confirm that the sort of linear combination of these effects is also in the same sort of ballpark magnitude. So this is for stage C, the de-anchoring. Now, what we also find is that in stage D, in our experiment, we don't find significant difference between these treatments in the degree to which people re-anchor to these, to the central bank forecast once it's updated. Now, we can get into that a bit, maybe in the questions afterwards, but we have some hypotheses for why that might be, not least the fact that in our experiment, we are actively incentivizing people to remain engaged, and try to forecast accurately and correctly. Right? In the real world, if people are de-anchoring, there is evidence out there that is associated with people disengaging, i.e. the more they de-anchor, the more they might disengage the central bank forecast. But we can get into that afterwards. One thing I haven't mentioned so far is that we not only have points versus fans, but we have 2 types of fans. We have a narrow fan, where the fans represent 70% of the distribution, and wide fans, where the fans represent 90% of the distribution. And what we find here for the forecast deviations is that there are basically no material differences between the wide and the narrow fan. Both initially increase the deviation from the optimal point in stage B, and both protect against or mitigate against the size of de-anchoring for these unlucky errors. Okay, so that was in expectation. I've probably got 5 minutes left. That was in expectation.
Matt, just you did well on time. I think telling people it was your birthday made them all a bit gentle because there aren't a deluge of questions coming in. So
either people are gobsmacked impressed, or
they may also be gobsmacked impressed. That's also possible. Or they're being very kind, in which case maybe the best birthday present for Matthew would be more questions. Right, carry on.
Okay, so that was testing the effect on people's sort of forecast accuracy or anchoring around the forecast. We also test the degree to which people update their confidence bands and degree of uncertainty around their own estimates. And in particular, what we say is, okay, we'd now like you to set a range around your point forecasts to express your uncertainty. Please choose a lower and upper bound for inflation in each forecast year and pick bounds that you will you think will almost certainly include the true value. So what we do is to sort of have a point of comparison. We compare participants' sort of confidence ranges with the interquartile range of the inflation back history as a sort of sensible ballpark. Now, we say this is a sensible ballpark. We tell them that their confidence ranges should span essentially the entire distribution of value. Right? And the interquartile range, of course, is sort of 50% of the distribution. But essentially what we find is that most people are extremely overconfident. Right? So even the interquartile range is larger than people's confidence bands. So we use that as our point of comparison, or as our lower bounds sensible ballpark. Okay, so here are the distributions. The distributions again here across all treatments, across all error types. And one reflects that their confidence band, their confidence range, is exactly equal to the interquartile range of the back history. Now, there are two things worth mentioning. One, most of the distribution lies to the left, i.e., most people are overconfident in their forecast range. Second, across years 0, 1, and 2, there's this hump just above 1. And that is the default range. So these are the people that are not changing their confidence range at all. So that was for stage A. So all they've done is they've seen the inflation back history. This is for stage B, where they are treated with the central bank forecast, and we see that people become even more confident. This is for stage C, once they've seen the error, basically no difference. And this is for stage D, once they've seen the updated central bank forecast. And this is again, basically no difference. Now, qualitatively, these distributions look quite similar across the points and the fans when we split out distinguish between the two treatments. But in the regressions, we find significant differences. So firstly, if we focus on the constants, and the constants are taken from the sort of no fixed effects model. One thing I haven't mentioned is that throughout we were able to have participant fixed effects. What we notice from the constants is this overconfidence. Each of these coefficients are smaller than 1, which means that their confidence ranges are smaller than even the interquartile range. The fan, relative to the point, increases people's confidence range towards something that's more sensible. So these are all positive increases in people's confidence ranges towards the interquartile range, which would be 1. And they do this at each stage B, right? So for the initial central bank forecast, but also stage D, right, for the updated forecast. And we see some effects of interactions of this being larger for people who also receive the unlucky. Now, that was for both types of fans together. We now show the distinction between the narrow and the wide fans. Right? And what we see is that the wide fans, I mean, intuitively, but it's nice to see it in the data, what the wide fans are really driving this result. Right? So it's when people observe these 90% fans that they are sort of learning best to develop sensible sort of uncertainty ranges. Right? So it's the wide fans that are increasing their ranges statistically significantly in this row. And we see these interactions with error types, right? So when people are treated with wide fans and observe these sort of unlucky and large positive errors, they really increase their confidence ranges to something that is very close. If we add this number 0.82 to 0.14, something that's very close to 1, i.e. something that's very close to the interquartile range. And that's true in stage C, but also stage D. So I cut a load of, I presented this material yesterday and I was told that I had too much material. I've now cut a bunch and reached the end. So I guess I'll open the floor for some questions after I make. Maybe I'll leave us here with the conclusion slide. If there are no questions, then I can also sort of talk a second about some policy implications. You're on mute, Michael.
Sorry, there are some questions. So yeah, thanks very much, Matt. That's I mean, I'm completely biased because I've been involved with this, but I do think it's an interesting question. Uh, okay, let me jump in. So there's one very technical question, which I think I know the answer to, but it's which is going to be we're going to have to get back to you on this. But Sophie asks. Essentially, can we do these regressions? And this actually is related to a question from yesterday, which I think it's worth discussing as well. Can we do these regressions acknowledging that, for instance, with the absolute values, we only have positive numbers, like a gamma specification or something like that? Um, I guess I'll let you answer that in a second, but let me throw in the question which I liked from yesterday as well, which was Simon Lloyd's question, actually, I think, which was about whether it's worth exploring. If you think about for some of these results where we only have positive values, the really interesting stuff might be the stuff happening in the upper tail. You might not care so much if it had little effect on the mean where people are within sort of 50 basis points of the central bank, but you might care a lot about getting the people who are 150 basis points back to 100 basis points or something like that. So there's two things for you to mull over.
Do we want to collect questions and then?
No, start with that one.
I mean, so again, I'd like to reiterate that I think that's a good question, and it's definitely something that we should look into in relation to. So I mean, well, a few things. One, we choose to focus on the absolute, right? Exactly because for the regressions, it means that everything is positive. So it aids the sort of interpretation. I guess one thing that I would say on that. So I mean we can look into gamma specifications and we can sort of take that offline. But I mean one thing I'd say is when we look at the non-absolute, right? So when we just plot the forecast deviation and look at whether people are below or above, those distributions actually look quite symmetric observationally. We can think about how we might dig into that more in sort of regression space. But it's not the case that sort of, for instance, people are consistently too high. There are also people, or an equal number of people who are also low. But I'd be interested to, I mean, yeah, it's something that we need to think about more, and specifically the gamma specification.
Okay, Robert Goodhead at the Central Bank of Ireland asks, why did you ask them to give a range that would almost certainly include the true value, as opposed to somehow eliciting a narrower confidence set, like 68% or whatever? Does almost certainly mean they end up thinking about the tails of the distribution?
Well, I mean, the immediate response to that is we've asked almost certainly, right? And their distributions are extremely tight. So, uh, so if we hadn't asked almost certainly, I mean, it would be an interesting question. I mean, the reason why, I mean, that's one comment just on in terms of the responses, right? So even when we ask them to basically plot everything or account for everything, the distribution is much smaller than the interquartile range, typically. Right. So that's one. Then the second point is the reason why we said almost certainly is because the way in which we financially incentivize people is we essentially give them an incentive. We basically say you will get money if the inflation outturn is within your band. Right? So now the amount of money that you get is sort of decreasing in the size of the band, but that was the incentive. So providing anything else, I think, would have been slightly contradictory with that financial incentive, or with the way in which we set up that financial reward structure. Hope that answers your question.
Yeah, I'm gonna add. Let me add one little extra bit on that. I think in general, this is bridging into the next question, and something I might add after you've answered that one. But in general, it is slightly hard to ask very technical questions of the general public on uncertainty. So, I think there are ways you can do it. There are ways to try. The key thing I would stress about this is the fact that they were incentivized to give an answer that where the incentive structure is they get paid a bonus if the range includes the outturn, but the amount of bonus they get decreases as the range gets wider and wider. So in some sense, I think they would probably be more focused on the incentives And then there is a balance between, you could be absolutely guaranteed to get a bonus by saying -10 to +30% as the outturn for inflation, but the bonus you get is then essentially zero. So, yeah, that's just one thing. And actually, I'm gonna a question that just came in, and maybe we should have said this at the start, but I'm gonna answer Gabriel's question as well on both of our behalves, which is about the nationality. So these are all done on UK citizens. So to the extent that they have ever paid attention to their central bank, these residents all have a central bank that has for a long history um, been using fan charts. So I think there is an interesting open question whether chucking fan charts at an American audience who have looked at dot plots more often, or an audience that have never seen them, whether that has a differential effect. But um, I guess I'll use this as a bridge into Julian Pinter's question, which is, um, he says, it's not clear to me the policy relevance of this exercise in practice. Do you expect many people to be exposed to the information on the forecast uncertainty in practice? Could you extend a bit on the potential indirect channels? Um, yeah.
So my response to that is sort of twofold. So firstly, in the part A, we show that um, experts' preferences across the different types uh, forms of uncertainty communication are quite similar to the public in this experiment. In other work, which Michael mentioned earlier, we show that experts aren't perfect. So to the extent that they are also sort of subject to these sort of mental or priming of the effects that we find for the public, i.e., to the extent to which experts are not also just perfectly rational, and they also will sort of punish the central bank for not communicating uncertainty where there is uncertainty, and then observing forecast errors where that wasn't transparently communicated before, then to that extent, these results may be generalizable, but I agree that more needs to be done for that channel to be concrete. The other way in which I think, or the more sort of direct way in which this stuff filters down is ultimately the general public observe central bank communications as filtered via the media, basically. Now, to the extent to which the media sort of control C, control V journalism, which again, other work that Michael and I have on sort of complexity of language finds to be sort of a common source of journalism, at least amongst some papers, is to the extent that that happens, then so the central banks communicating through fan charts to try to mitigate these effects, to the extent that that then sort of filters through to what public actually see, or the way in which the journalists would describe central bank forecasts, then that's a slightly more direct way in which these things that the general public would be presented with them. We're not necessarily saying that the general public are going to be seeing these things sort of directly on central bank websites, but they will be filtered through the media. And to the extent that the media are affected by these effects that we find across uncertain communication versus not, and the degree to which they then transmit it. But I mean, I think it's a fair question, and it would also be nice to be able to repeat this experiment directly with experts as well. I guess the problem with the part B exercise is that we need a bigger sample than we need for part A, where we do have experts in there, and that becomes increasingly difficult for sort of to entice experts to spend more and more time. Well, there are fewer of them, but also to spend more and more time on these sort of surveys.
Yeah, let me add one other thing as well, and I'll well, there's two more questions, so we will go three more. But let me just add on that. I think a lot of us, rightly, because of who, we're interested in this topic and we think about it. And when we think about journalism, we think about the sort of high quality journalism, like I said, like the FTs, the Wall Street Journals, the sort of high-end papers in our country where we have very competent, very good journalists, right? So, your Chris Giles is, we don't think he is sort of staring at this stuff, wondering, he might be wondering what the hell the central bank is doing, but not because he doesn't understand it. Um, Whereas, I think the papers that are typically read by a wider cross section of the population are not necessarily sending economic experts to do this stuff. And so, in that sense, that they probably are closer to the general audience. And I would say one last thing about prolific, which is, I mean, a lot of the people who take part in the prolific platform are people interested in helping science and progress on research. And so in that sense, we do have a bit of a selection going on, which is these people receive an email that says, we would like you to do a survey asking about inflation. And if they have zero interest in inflation as a concept, they just say, no way in hell. And so, in the same way that there's a subset of the population who don't ever look at a newspaper article, turn off the TV or radio, or certainly don't click on the central bank website because they're disinterested. We sort of have them, but they're sort of selected out. So you can think about this as accessing the 50 or 60% of the population who might be interested, but equally may not be like technically trained. Let me go. There's a couple more questions, Matt. So we'll just keep going. I know some people leave, but we keep it going for a maximum of 13 more minutes, but it won't go on that long, I don't think. Um, Gabriel.
I can actually read them.
Oh,
I found them on my screen, so I
oh,
can go through them.
yeah, but
So,
I like to introduce the people.
sorry, go.
So there you go. So Gabriel's question then is, because the rest of the audience can't see them, so we have to be
Sorry.
clear. Um, is a question about the trade-off between influence today and influence tomorrow. There's this other subset of communicators who communicate narratives, and they don't really care about their reputation tomorrow. They can just make claims today, and they're sort of done. And the question is, does too much honesty about how much the central bank don't know leave the field open to others who pretend to know and who may flood the information space and make it more difficult for the central bank to get through with its honest comms of uncertainty?
I'll take Winnie's question first, which is about consumers not liking, and then I'll get onto that one. On Winnie's question, as to whether we looked at the difference between unexpectedly high or low inflation. So we do. So we randomly assign, or rather, participants randomly see positive or negative shocks, and large positive or large negative shocks, or big positive, big negative shocks. And we do see an asymmetry. We find evidence that positive shocks impact people more. They de-anchor more than the negative shocks of the unlucky variety, as you suggest, and the fans mitigate against them relatively more as well. So that's exactly the mechanism that we do find, as you hypothesized. On Gabriel's question, so I mean, I think it's a good point. I mean, the central bank is competing with sort of, if not malicious actors, then people who are not necessarily intent on communicating the truth and nothing but the truth. And I mean, that's a dimension that's very difficult to hypothesize around. I guess one instinct is that doesn't mean that central banks have to either stoop down to their level or not follow practices that they believe are would promote sort of their comparative advantage, which is reliability, credibility, and trust. And to the extent that communicating and transparently that there is uncertainty enhances trust, then that sort of promotes that comparative advantage that I think central banks should continue to try to promote.
Yeah, let me just try, because I totally agree. I think if anything, I interpret our results as more favorable for central banks, because it may be true that you're fighting a different actor every time with a potentially malicious narrative, or sometimes just a different narrative. But again, I think what we found, and a lot of the literature so far looked at a kind of static thing, and yeah, we haven't gone that dynamic, but we've added one layer of error and re-anchoring or not. And you do see that, essentially once you've gone through this cycle, people realize, oh, they do make mistakes. Everyone can make mistakes. And ultimately the anchoring has no difference. And you get this positive effect on their beliefs about uncertainty. So, yeah, it may be awkward in a static sense, but I think dynamically it still makes the right thing to do to be honest and transparent about the amount of uncertainty. Okay, I've got two more questions to go. I'm going to do them in the order they came in. So, Petra's question: have you considered only the communication of inflation forecasts, or other variables like projected policy paths, where you could also use a fan chart or something like that to display uncertainty?
That's a great question. And in the initial design of the paper and the experiment, I had uh, we had policy paths in there as well, policy path uncertainty in there as well. So it's definitely something that we have thought about. We're keen to look into, um, and should there should be evidence on that, and I'm very sympathetic to your point of view that central banks themselves um, should or would could benefit from publishing at least optimal policy projections, and to avoid the risk of that seeming like commitment, providing some sort of form of uncertainty around those projections to communicate that that is not commitment, but sort of a model-based projection. I have a lot of sympathy for that too. I mean, I guess the reason why we didn't do it is because it was an extra level of dimensionality that I mean, the paper and the results are already so big that we had to take a course somewhere. I mean, there are multiple ways in which we do want to extend this. I mean, as I mentioned, I've only talked you through unconditional media today, i.e., sort of general uncertainty. We've also looked at more specific types of uncertainty, like scenario projections as well. And that's another that's another level of dimensionality, and another way in which this work could and probably should be extended. But no, Pedro, I mean, I absolutely agree that that is definitely something to dig into more and that we want to do.
Great. And then last question. We're going to end on this. Journalists have come up a lot, and so we have a journalist, turned academic in Alessandro Merli here asking the question, and it's the question that always comes up, which is, people aren't getting their information from traditional media. And again, I was talking about the FT versus, say, a Daily Mail, which is more widely read. He's thinking, people just don't look at either of those now, and they just look at social media. And essentially, then we have these echo chambers of people who all look alike. So does that change how the central bank should communicate their uncertainty? It's very similar to Gabriel's
I
question.
think it's quite similar, right? I mean, look, the ideal from the central bank's perspective is that their fan charts go viral every time they publish an MPR, a monetary policy report, and whether that's in tweet form or in um, on broadsheet newspapers, then that's ideal. I mean, I think the answer there is very similar to before. I think the central bank can only control what it can control. Whether it should have greater media presence itself, social media presence itself, I mean, that's a slightly separate question, and that's more a question of how can it get through to the public better, more effectively. But that question itself is separate to how it should communicate uncertainty most effectively. I think that question is more related to how can it engage with the public more effectively. And I guess our research here, which Michael and I have a paper sort of getting into some aspects of, but I mean, I guess our focus here is on specifically, okay, conditional on engaging with, how do you best engage? Oh, sorry, how do you best influence positively, both in terms of expectations anchoring and trust, credibility, reputation, etc. Conditional on that.
Yeah, let me add a last little bit because it sort of relates also to Gabriel's question, and I like the way the second question made me think about my answer to the first, and that would be, actually, I can see a world where if there are people out there who decide they want to take a pop at the central bank, and I'm sure there are many, um, I guess not communicating uncertainty may even give them more ammo. So there is, on one hand, yes, that you're revealing we don't know it well, but if you think inflation is going to be 3% and then fall to 2.5 and then 2, and inflation ends up being 4%, and people go, oh, look, those guys, those idiots said it would be 3, and it's turned out to be 4. Maybe it's better that those people don't have as much ammo, because you said, well, I said it would be 3, but I also said it could be 4.5 or 1.5, and so, yeah, I don't know. I guess there is, this is related to the work. that is sort of implied on this slide here. One thing we didn't do here, but we thought about doing subsequently, is this point of if you do make a mistake and I'm going to use much less central banking language than Matthew has. If you haven't used fans or some other communication of uncertainty to cover your anatomy, um, is there actual more disengagement with you? Is there less, like, directly, would people be less willing to look at your pronouncements again? As Matthew said very clearly, here we were still paying people. They had to sort of keep going. So we don't get a fully true engagement story out of this type of experiment, but you could think about that. Anyway, it is 11 minutes past. This is a perfect time to draw this to an end and to draw another year of these to an end. So I would like to wish you all a good holiday season, especially those of you celebrating. A good birthday to Matthew, and see you all hopefully in the next one in February.